Okay, we're back. This is section 14.2, page 2. And as I promised you, we've got the formula for if we have multiple data values. So like 2 of something, 3 of something. Anyway, I'd like you to pause the video, go ahead and read the formula and the steps, and then start the video up again. Okay, so hopefully you had time to do that. So what is the formula saying? The formula is saying that you're supposed to add this, whatever it is, divided by add this. So if we think about what we did in this formula back here, we're going to do the same thing. We want to add up all the data values. We're just going to add the 12s. We're going to say 2 times however many there were, 2 times the data value. So however many times it repeats, you multiply that by the data value. Well, isn't that what it's saying over here? It's saying take the data value, which is x, multiply it by its frequency. Notice that it tells you that f is the frequency here. Okay, so that's what we're doing. And then we're dividing by the number, the sum of all the frequencies, which would actually give you the data points. Okay, so to get to the 18, how did we get to the 18 here? We said, well, there were 2 of these and 3 of these and 5 of these. So we were adding that, 2 and 6, and that's how we got the 18. So same thing here. Okay, so let's try this problem. First thing we're going to do is we're going to write down our data values. So what are our data values? 12, 14, 15, 18, and 21. So 12, 14, 15, 18, 21. Then we're going to write down the frequency next to it. So how many times does it occur? Well, 2. And then 14 is 3. 15 is 5. 18 is 2. And 21, there are 6 of those. Okay, now to make sure that we got, well, no, we don't have a way of checking. If they tell you how many people were sampled, that would be a good way to check. Okay, so then we want to figure out what x times f is. So this would be 24, 2 times 12. This would be 42. This is going to be 75, 36, and 126. And certainly you can use your calculator to figure those out. Then what do we have to add up? Well, if we look at the formula, it says add the x times f, which is exactly what we added in the numerator before. So let's go ahead and figure that out. So 24 plus 42 plus 75 plus 36 plus 126. Okay, so that's 303. So when we calculate this, we're told that x bar is equal to the sum, okay, of the x times f, okay, all over the sum of f. So that's going to equal, in our case, let's just keep going here, this total. So let's go ahead and put a total in here. Okay, so total. Sum of the frequencies, if we add those up, we see you get 18. And then if you add those up, we just added those and we got 303. So 303 divided by the total number of data values is 18. So let's finish it up here. We'll say 303 divided by 18 equals 16.833. Okay, so if we round it to the same place, we get that x bar equals 16.8. Okay, so a couple things. One is notice. That is the same value we got here doing it the long way, okay, which hopefully that's the way things work. You have 2 different formulas, but they give you the same answer. So this is the shortcut version, okay? Then, so here, what is it where the formula means? This right here, the sum of f. Notice that I wrote here, it's the total number of data values, okay? All right. So now what I'd like you to do is pause the video again, try your classwork that's like this, then come on back, okay? All right, here we go again. We're going to try this problem all over again. Only this time we're changing a data value. So it says, recall that the mean for the distribution, this was the first example we did in this section. The mean was 5.4. We want to replace the first data point of 8 with a 100, okay? And recalculate the mean. comment on the results. So we're going to say the mean. What is the mean? The formula says it is equal to the sum of x's over n. So x bar, that's x bar. I should have written that. So we're going to add all these up. We're going to add 100 plus 9 plus 4 plus 2 plus 10 plus 5 plus 5 plus 3 plus 3. All over how many data values? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what do we get? Well, we're going to get 100 plus 9 plus 4 plus 2 plus 10 plus 5 plus 5 plus 3 plus 3. That's 141. All over 9. So what does that give us? Divided by 9 equals 15.66666. So if I round it here, I would say it's equal to 15.7. Circle the answer. And then let's take a look at the answer and think about it. Okay, so our data values range from 2 being the lowest and 100 being the highest. Okay, and the mean score, the average, is 15.7. Now let's think about this. Suppose that this is an exam and it's out of 100 points. And the students, these were their scores. One person got 100, and the rest of them scored these scores, 9, 4, 2, and so forth. Well, what would you say? Is 15 very representative of that data? When you look at 15, nobody scored 15. In fact, everyone scored much lower than 15 with the exception of 100. So that 15 score is really not very representative. That makes you kind of think that the data value should be around 15. Now, if you look over here, this first problem was 5.4 representative of the data. Yes, it was, because all of the scores were somewhere between 2 and 10. So for an average of 5, you even have 2 data values that were 5. That makes sense. So what are we learning? We're learning that when we have a data value that's way off of the other data values, it changes the average, right? Yeah, that's why, when you have, you've heard when curves happen in a class, you don't want one person to score really high. That messes up the curve. Okay, we're going to learn a little bit more on the next page. That concludes page 2. We'll go on to page 3.